So hello everyone, let us see in this videos about the different types of event we have discussed in the previous video. So here we will discuss the algebra of events. Again, very important topic we will discuss here. So watch the video till end. Fine. So see here the algebra of events, right? You know that what is the meaning of algebra? Adding, subtracting, these all operations we are doing on the algebra. So here on the set of set chapters, we have already studied about the different ways of combining the two or more sets. You know, actually probability is very much here in the class 11th and 12th related to the set theory set chapters, right? So see, for example, we discuss about the union, we discuss about the intersection, we discuss about the difference of two sets, we discuss about the complement of two sets, right? So this we have discussed. Okay. So these are the things here we have to discuss, that what is the meaning of that actually. See. So likewise here, what we are going to do, we can combine two sets or more sets, right? So using the analogous set notations. We already discussed about the what is the notation of union, intersection, these all things. So that we will use here. Fine. So let us suppose here we have a set A, right? We have set A. We have another set B, right? We have two different events. So if we want to find the let us suppose the A union B of events, so we can use here. We can find A intersection B, right? We can find A minus B. We can write not A, that is complement of event A, right? So these all things we can do here. And see, actually this probability actually we can learn with the help of like Venn diagram. And if we use the Venn diagram, it's will be very easy for us. See, what we will suppose, we will assume whatever is our total sample space, we will consider as the universal set like S, right? And all the events will come inside the sample space, so that we will consider as the subset of this set, or that is your subset of the sample space. And you already know what is the events. Events is nothing but the subset of sample space. Let us suppose this is your A, this is your B. So here you can see some portion is common here, so some sample point that are in events A also and also in events B. So we can find that common point, sample point. We can find union, we can find intersection. So these all things we will discuss one by one later. So first of all here we are going to discuss that complementary of an event, right? So what is the meaning of complementary of an event? So see here, if I try to show you here first using the Venn diagram, it's very easy. That I told you that this universal set we will consider as our sample space, right? And if we are taking any subset inside the sample space, or that is your what actually, that is your events, right? So inside sample space, this is what actually, that is your sample space. This is nothing but your sample space, that is your universal set. And what is this? This is your events inside the sample space. Now if we consider about the complementary of an event, means that elements is not in that event. So see, for every events A, there is corresponding to the another events is called the complementary of event A, and that is called not A actually. Let us suppose this area of the sample space is denoting your events A. So this much outer area, this all outer area will be representing your not A. So this will represent what? This will represent not A, or it will denote in this way or this way or somewhere like that, or it can be written as not A or complement of A, all are same. Okay, so this is we have shown you using the set theory method. Now let us see here if we see the examples here. So let us take an example that tossing 3 coins. So we know that if we toss 3 coins, so these are the outcomes. Total 8 outcomes are there. And if we consider A is an event, only one tail appears. Only one tail appears. So you know, only one tails. This one is there. Only one tails. This one is there, and this one is there. So total 3 sample points are there. On which only one tail is there. Right. So if someone asks you what is the not A here, or what is the complement of A here, complement of A, complement of A. So complement of set A or complement of event A is what actually those outcomes or those sample point in which uh, not one tail appears, means all the other sample point except these three is called as the part of our not A. So you can see here, you can write this one, this one, this one, this one, this one. So this all are the part of your not A. Means simply can write that is your all sample space minus A. So from the sample space, if we subtract this the given events, that you will get not A actually. Here also you can see this is nothing but your what? This is your complete sample space, and if you subtract this portion of the set A, so that you are getting the what? That you are getting the complement of the set. So hopefully it is the same written here. So hopefully you got the concept related to the complementary events here. Fine. So next is what actually next here algebra we are going to discuss that the OR, that is the union we know that OR means union and means intersection here. So we all know that the union of two sets A and B is denoted by this union. So A union B. Fine. So contains all those elements which are either in the set A or in the set B or in the both. Very important. So in the A union B, we have to write those elements either present in the set A or present in the set B, or if it is both, please no problem. So that is the, if we consider all, that is the union. Hopefully you remember how to write the union of two sets or three sets. So when the sets A and B are the two events associated with the sample space, then A union B is event either A or B or both. So events A union B is also called A or B, right? So this is A or B here. Okay. So see if I can show you using the Venn diagram. So see, let us suppose this is here you have the sample space, right? That is, you can say the universal set. Here you have taken one, let us suppose events A or even events A, and here you have taken, let us suppose, events B. Let us suppose this is event A and this is event B. Let us take a practical example that throwing a dice. Let us throwing a die, right? Here we have thrown a die. So we all know that what is the outcomes? Outcomes will be 1, 2, 3, 4, 5 or 6. This is the total 6 outcomes are there when we are throwing a die, right? Okay, fine. Now let us suppose A is an event. A is an event that outcomes less than 4. Less than, it is supposed to be 4, right? Let us take B is an event in which outcomes are more than 2, more than 2, right? Now see, in this case what situation happen here? So here you can see A is an event in which outcomes are less than 4, means up to 3 can be here, right? So and here outcomes more than 2. So you can see this is, you can take here 1, you can take here 2, right? But 3 let us left for the standing 3. And outcomes is more than 2 to 3 is also there. So you can see 3 is present here in the set A also, in the set B also. Means this is the space where present in both, in events A also and events B also. So 3 will be in the A also and also in the B. And what about the 4? And then you can write here 5 and you can write here 6, because it is given that outcomes is more than 2, means this all come in B. Outcomes is less than 4, so 1, 2, 3 will come in the A. Got it or not? So here you can see what is A union B in this case, if someone want to write actually. So A union B for this situation is actually complete state, that is 1, 2, here 3, 4, 5 or 6, right? So A union B means what actually, whenever you are writing A or B or A union B, its simple meaning is that either your element belongs in the set A or in the set B. So whatever the elements you have, either it belongs to the set A or it belongs into the set B. Okay. So this is the case here. So in this case, in this way, we are finding the A union B. Hopefully, it's clear to you. Next, let us complete this also. The AND event means intersection portion. So what is here? The intersection. So we know that the intersection is the, this is the symbols we are using for the intersections, and the set of those elements in which the common, so it should be common in both, right? So element or your simplest point should be at the A also and it should be in the B also. So that's why here AND is coming. So it belongs to the A and B. So this is the its representation. So if you are taking any elements W, so W should belongs in the A also, and this is very important word, and it should be belongs in the B also. So this is actually A and B. So if I take the above example, so in A intersection B, 3 is there, right? You can see this 3 1. So 3 1 is present in A also and it is in B also. So with this example we can write here for this case. So in the above example, if you take above example you can take, so what is A intersection B? This is actually what 3 here, right? So in the simple in the events A, that is 1 2 3, in the events B, that is 3 4 5 6. So this is common at both the place, that is the intersections. Fine. Next one is here, that is what actually see the events A but not B, right? So you want A but not B. So that is actually nothing but A minus B. That is the A minus B. So set of all those elements which are in A but not in B is called A but not B or A minus B. Therefore, set A minus B may be denoted the events but A but not B, right? So this is the case here, right? Let me show you using the Venn diagram. So if I can show you using the Venn diagram, let us suppose here, this is your sample space or that is your universal set S. Let us suppose here we have two sets, set A and set B. Set means here we are saying the events, right? So don't confuse with that. That is your A and that is your, let us supposed to be B. So what is given here? A minus B. A minus B. Means we have to remove all part of B from A. So you can clearly see here. So this is the portion you will get. This is the portion, because the portion that present in A as well as in B. So we have to remove that one. So this is the value of part actually, that is your nothing but that is your A minus B. That is your A minus B. And you can see what is that actually, that is the intersection of A and B complement. B complement means outside that, and if you are taking the intersection of A, so this is the same. So hopefully you get this concept. So A intersection here, B complement, right? So this is the case for the A but not B. Okay. Means if I can say in the above example, let us write here. So in the above example, in above example, in above example, what is the situation here? See, there is actually 1 2 here, 3 here, 4 5 and 6. So here the answer will be what? Our 1 and 2 only. What is the a minus b? Actually 1 and 2 only. If you write here a minus b, that is your 1 and 2 only. So hopefully this part is clear to you. So let us take one question here. In these questions we can find all the things, and whatever we have learned, it will be very clear from these questions, right? So see the question. Question saying here, consider an experiment of rolling a dice. Okay, fine. So let us first write the simplest space here. What is the simplest space where we are rolling a dice? So simple space. Simple space will be having point 1, 2, 3, 4, 5 and 6. Okay. Let A be the simple space, getting a prime number. Okay. So A is the event we have made. What is A? A is an event getting a prime number. Okay, na? Getting a prime number. Getting a prime number. Getting a prime number. So we all know that what is prime number here? 2, then 3, then 5 are the prime number. 2 is the only prime number that is given, and 2 is the, you can say, the only prime number. This is the smallest, you can say, or maximum, you can say, the even prime number, right? Then B, what about the B? B is the event getting an odd number. Okay, so this is getting an odd number, getting an odd number. So see, what is the odd number here? In this case, either 1 or 3 or 5. Fine. Then write the set representation. So first of all, you have to write A or B. So A or B is also can be written as A union B actually. So simple. We have two sets at the union, that is 1, 2, 3 and 5 is the answer here. A union B. Okay. If we solve the second question, is there what? A and B. So A and B. A and B means nothing but A intersection B, means we have to write the common point. So 3 and 5 are the common point here. Now next, if I look at here, third one. So third question is talking about A but not B, right? A but not B. But not B means you can say that is A minus B. So see, in A whatever B is there, you have to remove that one. So 3 and 5 that present in B also, so we have to remove that. So that is only 2 we are getting. So A but not B means only 2. Fourth, if you take here, that is not A. What is that? Not A, right? So not A means what? So simple space minus A, you can say, right? Simple space minus A. Simple space you have 1, 2, 3, 4, 5, 6, and you have to subtract A means 2, 3, 5. You have to delete from here. So what you will left now? 1, then 4, and then 6. So this is the not A. If I can show you very quickly in the Venn diagram also, let us see. So this is the sample space whenever we are throwing up dice. So this sample space we are getting, you have actually here 2, we have here what? Total, we have 2 events, right? Events A and events B. This is our events A and this is our events B. Okay. So events A having the number 2, 3, 5, and 3, 5 is also there. Let us first write the common point, that is 3 and 5 is the common space. After 2 is here and here, 1 is here, and 6 is not in A and B, so let us 6 is somewhere else. Okay, so this is actually the set representation of this question. So now first is A or B. So clearly you can see here A or B means those that are coming in that portion, that is the same here. 1, 2, 1, 2, 3, 5, that is here I have written. A and B in the intersection value, that is 3 and 5, you can see. A but not B, right? So only 2. right? This area, no? This is the area that representing what? That representing your A but not B. This is A but not B, or you can write A minus B. It is the same as A but not B, this case, right? Not A means outside that, so this is nothing but simple space minus A. This is the case. Not A means that is not in A. Okay, so what is that actually? 1 and 4 is also here, so 4 and 6 are there, so 1, 4 and 6. So this is the case here. Hopefully you get the concept. Fine.